Okay, this is another part of the previous question that we did during practicals. So let's assume that we have now used ammonium solution. Ammonium solution is just ammonium hydroxide. So ammonium solution is also used to test for amphoteric ions. So we learned that there are three amphoteric ions: aluminium, lead, and zinc. Last time we learned that when we use sodium hydroxide and white precipitate dissolves in excess sodium hydroxide, we write all of them: aluminium, lead, zinc, present. So the three amphoteric ions, they are always soluble in excess. They dissolve. They form white precipitate in few drops of sodium hydroxide. And the white precipitate dissolves and form a colorless solution in excess sodium hydroxide. But when ammonium solution is used, out of the three amphoteric ions, it is only zinc that dissolves in excess ammonium. So when white precipitate forms, and this white precipitate dissolves in excess ammonium solution, we only write zinc present, but we don't write all of them because aluminium and lead are insoluble in excess ammonium. They form white precipitate in few drops, but this white precipitate fails to dissolve even when we add excess ammonium. So when we, for example, let's focus here. To the second question, add ammonium solution dropwise until in excess. So we add few drops, we make observation. So few drops are between 1 to 3 drops. When we add 2, 1, 2, 3 drops, we expect white precipitate to form. Then excess are uncountable drops. We just add drops without counting how many drops. So what we expect is the white precipitate. We expect that white precipitate to dissolve and form a colorless solution. So according to this, our question, this is the observation. White precipitate, comma, soluble in excess ammonia. We can also state it this way. White precipitate formed that dissolves in excess ammonia. So when white precipitate dissolves in excess ammonia, we have to write zinc ion present. So, okay, when there are three suspects, and we want to say that one is present, of the three suspects, only one is guilty. So when I say one is guilty, that means that the other two, they are innocent. Okay, when we say that zinc is present, alternative answer for zinc is present is aluminium and lead, they are absent in that solution. So when we say zinc is present, it's the same as the other two are absent because qualitative analysis tests for these cations and anions, including organic compounds. We use elimination method. What you say present up there, you should not again talk about it being present in the succeeding question. So in this case, when we say that zinc is present, we cannot again say that zinc is present in the succeeding question. So because white precipitate dissolves in excess ammonia, we can say that zinc ion present. We can also state that or aluminium or lead ion absent. So to say that this is present is the same as to say that these two are absent. Okay. In most cases, we are discouraged from using the word absent unless we have no option. And another instance where we can choose this one instead of this one, we look at the marks given in that question. For example, at this side of the question, the mark, we are only given 1 mark. And on this side of the question, it is also another 1 mark. In test for these ions and even organic compound, in most cases, every ion written is half a mark. So that one means that if we choose this answer, we can get half a mark for just stating an answer with only 1 ion. But if we choose this alternative answer, we will get 1 full mark because every ion is half a mark. So it depends on what is given there. If it is half a mark, then we can just take this one. If there is 1 mark here in bracket, then we should not choose the answer that will just give us half a mark. We can choose answer that will give us 1 full mark. So at this point, we look at the marks given down here. Yeah, so when white precipitate is soluble in excess ammonia, we can either say that zinc ion present or aluminium or lead absent. So I've said this one, we can only choose it when we don't have alternative. For example, in testing for solubility test, colored and colorless ion, the way we discussed in the previous session. So when a solid dissolves to form a colorless solution, it means all the colored ions are suspected to be present in that solution. But when a solid dissolves to form a colored solution, then we know that one of the colored ions may be present. If the solution is blue, we will only talk about copper ion present, brown, ion 3 ion present, green, ion 2 ion present. So in that situation, we are only allowed to state the 3 colored ions as absent because colorless ions are so many and we cannot state all of them within this space. So that's where we are allowed to state, to use the word absent when we are mentioning the 3 colored ions. So we can either say that the 3 colored ions are absent, or if the solution is colored, then we mention the specific color and we connect it with the color of the ion that always make the solution to appear like that. If blue, copper 2 ion present. Green, ion 2 ion present. Brown, ion 3 ion present. But there are some experiments whereby we also test oxidation, how oxidation takes place. You may add a certain solution, a green color forms. Then after some time, the green color changes to brown. In that case, ion 2 ion is formed, which is further oxidized to ion 3 ion. So when ion 2 ion forms, the solution will appear green. Then after some times, the green solution will turn brown. In this case, further oxidation has taken place. Oxidation is the removal of electron from an atom or already ion form. For example, ion has more than one oxidation state. So ion 2 ion is green. When a green solution changes to brown, it means ion 2 ion has been oxidized further into ion 3 ion, which is a brown one. So under that circumstance, in that circumstance, we will be talking about ion 2 ion has been oxidized to ion 3 ion. But on this, we only talk about the 3 amphoteric ions, but I've said we can only give alternative answer depending on the marks given in that bracket. So if we find that the white precipitate, let me write here. If we find that the white precipitate becomes insoluble in excess. If the white precipitate becomes insoluble in excess ammonia, like this, white precipitate, comma, insoluble in excess ammonia. Look at this. The white precipitate now insoluble. The white precipitate does not dissolve in excess ammonium solution. So when this one happens, we mentioned the two ions that will never dissolve in excess ammonium solution. Out of the three amphoteric ions. What did we say about the amphoteric ions? So amphoteric substances are substances that it possesses both acidic and basic properties. According to chemistry, these ions are able to react with both acids and bases. In some reactions, they react as bases, but in some reactions, they act as acids. When they react as acids, they form different compounds from when they react as bases. So at this point, of the three, zinc, aluminium, and lead, when white precipitate becomes insoluble in excess ammonium solution, then we mentioned the only two out of the three amphoteric ion, that is aluminium ion, lead ion present. Because out of the three, only these two are insoluble. They form white precipitate that is insoluble in excess ammonium solution. So do not write zinc absent. I say we are discouraged from giving negative answers. So we dwell on positive answers. So instead of writing zinc absent, that will earn you 0 mark, just write aluminium, comma, lead present. So if a question comes like this, and in the first question we mentioned the three. When we use sodium hydroxide, we mentioned aluminium, lead, zinc present. Then in the next question, we have found out that when we use ammonium solution, always when you see ammonium hydroxide and sodium hydroxide, just know that we are testing for the three amphoteric ion and also copper. Copper ion is also soluble in excess ammonium to form deep blue solution. That one we'll talk about later. When a solution dissolves to form deep blue, that one we are dealing with a colored ion that is soluble in excess ammonia to form deep blue solution, a complex ion that makes the solution deep blue. But at this point, when we use sodium hydroxide and we have stated that aluminium, lead, and zinc present. Next question, we use ammonium solution to eliminate one of them, or remove one or remove two of them. So according to this question, ammonium has eliminated zinc. So that one means that if white precipitate is present, is formed, and this white precipitate fails to dissolve in excess, then we will now conclude that out of the three amphoteric ions, only two are present. So zinc has been eliminated from the three amphoteric ions. So it means this question still proceeds to part C. So in part C, use a different chemical that we will use to eliminate one of them. So we look at the properties of salts, their solubility, and how they look like, and which compounds dissolve them. So, and all which compounds they can form and color of those compounds. So next one, we must now move to part C of the question to eliminate one of the two amphoteric ions. So this is how we are going to form the third equation to ensure that out of these two, one is eliminated, we remain with the one. Because when we are given salt, we are given salt with one cation and one anion, unless it is a slightly soluble salt, that we will also perform other experiment with the residue after filtration. So part C of the equation, this is how it may look like. Part C. To the third question, to the third question, to the third question, comma, add, to the third question, add potassium, potassium chloride, double S, potassium iodide, we mean, add potassium iodide solution dropwise, meaning some few drops of potassium iodide. So when we add potassium iodide, all these reagents you must know what will happen. I said in chemistry paper 3, testing for this qualitative analysis, you are going to an exam room knowing all chemicals and what they are used for and expected observation. And you must know the expected inference. If what you know has not happened, you just refuse. Not happen. For example, potassium iodide, when it is used as a reagent, we expect a yellow precipitate. So when a yellow precipitate forms, we will just say yellow precipitate formed. When it has not formed, we will just say no yellow precipitate. So let's assume that yellow precipitate formed. So yellow precipitate, yellow precipitate formed. Yellow precipitate formed. So out of these two ions, it is lead that forms yellow precipitate with potassium iodide. So if you see yellow precipitate, just know that lead ion is present in that solution because lead ion forms yellow precipitate with potassium iodide reagent or solution. So at this point we will eliminate aluminium. So we will say that in our inference, we will just state that lead ion present. Now aluminium is absent there because aluminium does not form a yellow precipitate with potassium iodide. Aluminium does not form a yellow precipitate with aluminium with potassium iodide. So because yellow precipitate is formed, we remove aluminium. So potassium iodide has eliminated aluminium. When if at all we were to use another reagent in the next question, we are not allowed to state aluminium anywhere because it is like saying that aluminium ion is not there. In that experiment, we don't mention aluminium anywhere because when you state that lead is present, it's just like stating that aluminium ion is absent. But if yellow precipitate not formed, now we talk about aluminium ion present, but lead ion is absent. So when you say or no yellow precipitate, no yellow precipitate. So when you say no yellow precipitate, I say in chemistry qualitative analysis, what you know has not happened, just reject. No yellow precipitate. That means that I read my notes and I knew that when I see potassium iodide, I'm given potassium iodide what I have in mind is that there must be a yellow precipitate forming by the time I'm using this reagent. When I see ammonium solution, I know well that a white precipitate is to form, and this white precipitate must dissolve in excess of this reagent. Same to sodium hydroxide. So when we use potassium iodide and no white yellow precipitate form, we will be talking about aluminium ion present. Don't write lead ion absent. Why are we just stating this two? Because they were the two remaining amphoteric ions that we are now dealing with after sodium hydroxide has ammonium has eliminated zinc. So out of the two, when we say that no yellow precipitate formed, we will only mention the other one of the two remaining, aluminium ion present. But if yellow precipitate forms, we only mention lead ion present. So apart from potassium iodide, we can also use sodium chloride, or we can use hydrochloric acid. Why? Because of the two metals, of these two metals, aluminium and lead, of these two metals, solubility test states well that lead chloride forms white precipitate, meaning it is insoluble in any chloride solution. That one means that lead chloride is insoluble in cold water, and it can only dissolve when the water is warm, when the mixture is warm. So we say that white precipitate forms soluble on warming. But when we are dealing with something like this, there is no warming, because as long as a white precipitate will form, we will only be talking about lead present in that solution, because aluminium chloride is soluble in aluminum chloride is always soluble, so it does not form white precipitate. So we learned that all chlorides are soluble except lead chloride that dissolves on warming but insoluble in cold water, and silver chloride, which is totally insoluble. It will always form white precipitate. But silver, we cannot mention silver in paper 3. In most cases, we don't use silver in our laboratory. Silver is a very expensive metal, and I don't think if there is a school that can acquire silver, gold. That's why in most cases we don't mention silver, gold as one of the ions tested in qualitative analysis. So our schools cannot afford the two metals. So because of that, we just know that when we are using sodium chloride or hydrochloric acid, we are testing for soluble, insoluble chloride. So there are only two insoluble chlorides, but one is soluble only on warming. Lead chloride will only dissolve on warming, but silver chloride we cannot use because we cannot afford that metal in our laboratories. So if we use, for example, potassium iodide, sodium chloride, yeah, we expect a white precipitate, sodium chloride. So when you use sodium chloride, we expect a white precipitate. So let's assume that white precipitate formed. White precipitate formed. White precipitate formed. So if white precipitate forms, and the two ions that we add, uko juu, it is up there, aluminium ion and lead ion. When we use sodium chloride and white precipitate forms, now we will not mention aluminium, because all aluminium chloride does not form white precipitate. So we will only be talking about lead ion present. That one means that aluminium is absent there because white precipitate does not form. So if, because white precipitate forms, if aluminium was there, white precipitate would not form. So at this point, we will mention lead ion present. Or if no white precipitate forms, no white precipitate, let me write it in short form, formed. No white precipitate formed. Now we will omit lead because lead chloride forms white precipitate. So at this point, we will mention aluminium because its chloride does not form white precipitate. It is a soluble chloride. So at this point, we will say aluminium ion present. Aluminium ion present. But if white precipitate forms, lead ion present. If no white precipitate, aluminium ion present. So if we end up with this answer, then our conclusion is that part of the component of that solid given was aluminium. So at this point, we move to the next question to test for uh, an ion that was in that solution, because it was a compound of aluminium and another part is an ion. So I say, instead of using sodium chloride or potassium iodide, so in the place of sodium chloride, we can also use hydrochloric acid, because hydrochloric acid will also provide chloride that may react with lead to form lead chloride that may form white precipitate. So instead of sodium chloride, we can also use hydrochloric acid, HCl. So these two reagents are used in place of another one. If one is missing, we can use the other one. Just like acidified potassium manganate 7, purple. If acidified potassium manganate 7 is absent, we can use acidified potassium dichromate 6, which is orange. It's just like when there is no sodium chloride, we can use hydrochloric acid. So that's all about what we were to discuss on the remaining part of the question. So tune in for the next part of it, where we will be testing for an ion